Good morning, students. You're right. We are on the topic statistics. Yes, I think you observed and you understood and you learnt the derivation of the formula of deviation method of finding arithmetic mean. Isn't it? Do you remember the formula? Tell me once. Very good. X bar is equal to A plus sigma FD by sigma F. Very good, very good. What is A? Right, assumed mean. But this must be kept in your brains very clearly that the assumed mean you have to take from the mid values. So if the example is given to us in this manner, find arithmetic mean of the following by deviation method. The classes and the frequencies are mentioned here. Okay. So what do you want to find here? Right, Nana, mid values. You want to find mid values as I gave you yesterday the model table, isn't it? In the previous video I gave you the model table. In the model table you want to find the mid values. Can you tell me the formula for mid value? Very good, Nana. LL plus UL by 2, lower limit plus upper limit by 2. 0 plus 10, that is 10, 10 by 2 is 5. The next 10 plus 20, 30, 30 by 2 is 15. So what is the gap here? 30. How much the gap? Yes, 10. The same gap you can see here. What is this gap called? Right, class interval or size of the class. Okay, right. Now you add that size, you get 25, 35 and 45. Okay guys, right. Now direct multiplication means that is a direct method. But this method is based on deviation. So where you need to find deviation. Very good, Nana. What is the formula for deviation? Deviation di is equal to xi minus a. Xi is nothing but mid value. And what is a? A means assumed mean from the mid values. Clearly, completely you have to spell that one. A means assumed mean from the mid values. See, these are the mid values, isn't it? From these mid values you have to take any one value, any one as you wish. You can take 35 or you can take 5 or you can take 45, 25, anything. So take any value as A, assumed mean. Okay, right. Now xi, that means x1 minus A, 5 minus 25, you will get minus 20. 15 minus 25, you will get minus 10. 25 minus 25, you will get 0. 35 minus 25, you will get 10. 45 minus 25, you will get 20. Okay guys, very good. These are your deviations. Now you want to find Fi into Di. Very good, Nana. Fi into Di. You understood, very good, very good. Fi into Di. Come on, tell me what is the frequency here? 7. 7 into minus 20, minus 140. 6 into minus 10, how much you get? Minus 60. 5 into 0, you get 0. 3 into 10, that is 30. 4 into 20, that is 80. Okay, you add the negatives and you add the positives. What do you get here? Minus 200. And what do you get here? 110. Okay, minus 200 plus 110, how much do you get, Nana? Minus 90. Very good. This is sigma Fi di. Sigma Fi di is minus 90. And what is sigma Fi? Sigma Fi, 6 plus 4, 10, 7 plus 3, 10, 20 plus 5, you will get 25. Okay, right. Now come to the formula. What is your formula to find the arithmetic mean? So arithmetic mean, x bar is equal to, come on tell me, A, very good, A plus of sigma Fi di by sigma Fi. Okay, right. What is the value of A? A is nothing but 25. Very good. Plus sigma Fi di is minus 90. That is minus 90 upon 25. You cancel with 5. 5 5s are, and this is 5 18s. You can cancel again with 5 5 1s are, 5 3s are 15. So you get 0.6. This minus is there for you. So you get 25 minus 3.6. So 10 minus 6 you will get 0.4. 4 minus 3 you will get 1 and 2, 21.4 is your arithmetic mean. Okay guys, did you understand? This is the deviation method to find the arithmetic mean of a given grouped data. Okay, Nana? Right. Now you come here in the page number 327. In page number 327 you have a think discuss. See the first question, the mean value can be calculated from both ungrouped and grouped. Which one do you think is more accurate? Why? Can you tell me? We calculate for ungrouped and also grouped. But you observe in the ungrouped frequency table you can see all the observations directly, isn't it? X, 3, 4, 7, 8, 9. You can see all the observations. So direct observation can be observed there. But in the grouped data you will see a group, but you don't have any particular observation here. So calculating mean by ungrouped data is accurate. So the answer there, in ungrouped data we can observe the frequency, the observations directly. In ungrouped data we can observe the observations directly. Hence it is accurate. Okay. Next, second one. When it is more convenient to use grouped data for analysis, when you have maximum number of observations, when you have maximum, suppose 200 or 2000 or 20,000, in any company you have 2000 members working there, if you write all the persons indirectly, so it will take more pages or more space, more time to calculate, isn't it? So when the observations are more or too large values, when the observations are more or too large values, it is convenient to use grouped data. When the observations are too more or too large, then it is convenient to use the grouped data. Okay, Nana? Right? Right. Next, we are going to know how do we calculate the arithmetic mean by the third method. I said you, step deviation method. Okay, step deviation method. So according to the deviation method we came into the deviation, but what is meant by step deviation? So step is a function. Step is a function which is graphed as steps. Okay, this type of function is called as a step function, in which it is surely given as the value of yours is always an integer. The step deviation indicates that the values what you get in the deviations are to be changed into minimum integers. Minimum integers. Okay, instead of taking the class intervals, you are going to take the integer values. Okay, that will be discussed in the next class. Practice this question and same as do the two examples in page number 326 and 327. Practice those two examples. We will continue in the next video. Bye.